All right, so this is the challenge problem, but it's also one that I believe we can do. We just have to put together a lot of pieces of information that's in there that are not in the same way. And this is more like what you should expect on iLearn. It's making you think about all the puzzle pieces that goes together. So I might have to do some stopping and starting and you guys paying attention and stopping and discussing and that sort of things. But if you're at home, just pause and go along as we read this. So Macy leaves her house at exactly 7:36 a.m. to bike to school, which is 3.75 miles away. When she passes the post office, which is 1/2 of a mile away from her home, she looks at her watch and sees that it is 7:40 a.m. Okay, so pause and discuss and think about what things are being compared. We've done unit rates. Usually we're trying to figure out miles per hour, or cupcakes per hour, or things like that. It's a unit rate. How much per pound? What two things are being compared here? Push pause and discuss it at your tables, or discuss it with a family member or whatever, and come back and see. Okay, now that you've discussed, verify. I know that it is going to be time being compared to miles. So I'm going to say that it's probably miles per minute. Okay. So my step one is to identify what it is. And I'm going to say that it's miles per minute. Now I've taught you two different ways to try this. One, you know that per means divide. And the other way would be to set up what we call a proportion, which means miles over minutes equals miles over minutes. I know that there's been a preferred one, but I want you guys to think about how you would set this up. Write it on your desk, write it on a piece of paper, and then come back. Okay, so I'll tell you that some people might get stuck because it's got a time here, it's got a mileage there, it's got this picture. So with this picture, what do we know? We know that she has gone this far. This is her miles. So miles, but we don't know her time. And so this is where you have to think about, is there a way to figure out how long it took her to go 1/2 of a mile? Push pause, come back and see if you're right. Well, I could look. That's what this 7:36 and 7:40 comes from. So how long did it take her to get that 1/2 of a mile? I have to do 7:36 to 7:40. So I'm just going to count my head: 36, 37, 38, 39, 40. Oh, 4 minutes. Okay. So 4 minutes, she went 1/2 a mile. Now I might have something to work with. Okay. So I'm going to take this 1/2 mile, put it right here. I'm going to take this 4 minutes, put it right here. And I know per means divide. So now I might be able to solve this. So I'm going to do 1/2 divided by 4. So I keep, I change, and I flip. So 1/6 mile per minute. 1/6 mile per minute is how fast she's going. So that's the first thing that I've figured out. All right. I wish I could erase part of this. So next thing that we need to think about is what they want to know. So at 7:40, she hasn't made it to school. So let's keep reading. If Macy's school starts at 8, can she make it to school on time without increasing her rate of speed? Show and explain the work necessary to support your answer. So we've already figured out how fast she's going. But now I need to go figure out how far she's got to go and if she's going to make it there. I want you guys to discuss at your tables or think about it yourself and then come back. All right, so hopefully you guys have come up with a way to come up with this, but there's two ways that I can think of to solve this. Well, she's got to go 3.75 miles, and if I know that she goes a sixth of a mile per minute, I can take how long she had. So she had this much time to ride her bike. So I would do 8 o'clock minus the 7:36 and have to figure out how many minutes she had. So time might be difficult for me, but 8 o'clock is more like 60. Is 7:60? 7 hours and 60 minutes is the same. And I'm going to subtract that 36 minutes. So she's got 24 minutes before school starts. Okay. So if I take that 24 minutes and I times it by the 1/6 that she's going, 1/6 miles per hour, I should be able to see if she gets 3.75. So I'm going to do that. And multiplying fractions is pretty easy because it's just, across the top and across the bottom. So 24 times 1 is 24 over 6. 24 over 6, I have to reduce, and I get 4. So that 4 means she went 4 miles in 26 minutes. Okay, that's one way. Was she able to make it to school on time? How far was school? 375? Yes. So the answer is yes. Now, there is probably another way to do that. Let me see if I can come up with it and change colors. So some students may have set it up like I did. We know that she went 1/2, so we're doing miles over minutes, right? This one, according to me, is a little bit more complicated. So miles over minutes, she goes 1 mile in 6 minutes. We know that because she got a sixth of a mile in there. Okay. And she needs to go 3.75 miles in an unknown amount of time. So then we can cross multiply 1 times x, 1x equals 375 times 6, 3.75 times 6 equals 22.5. So she has 22.5 minutes to get, that's how long it will take her to get to her school at the 375. And I know that there's another way, but I'm not going to go into that right now. I just am going to show the two that I was aware of. So the key is there's lots of different ways to figure this out. We will have to explain. So down here, you guys should make sure that you explain. I first calculated that she was traveling 1/6 mile per minute. Since she has 20 minutes to get to school, I just multiplied or repeated addition the 1/6 by 20 times. I found out that she will get to school on time. So that's what I wrote. If you copy what I wrote word for word, not your best answer because you need to be using your own brain. Showing your work on your paper, that would be great. I did some with typing, but I know that you guys are going to need some paper to help you. So if you're at home, grab some paper.